Hello students, welcome into our first lesson. In this lesson, we are going to do the following. 1. We are going to define the moment of a force. 2. We are going to look at the factors affecting moments of a force. And 3. We are going to look at the activities where force produces a turning effect or the moment of a force. Let us start our lesson by looking at the definition of the moment of a force. And the moment of a force refers to the turning effect of a force. It is also defined as the product of the force and the perpendicular distance between the point of support or the fulcrum and the line of action of the force. So this is now the perpendicular distance. Okay, this is the line of action of this force, this direction. And then the perpendicular distance from this line to the point of support is this. And therefore, if you want to know the moment of a force, you take now the magnitude or the size of this force here multiplied by the distance from here to here. Thus, the moment of a force is equal to force times perpendicular distance from the point of support here and the line of action of this force. Therefore, we have force times distance. Then we have factors affecting moment of a force. And one of the factors is the amount of force. The amount of force applied here will determine how fast or how effective the force will be. And the moment of force is directly proportional to the amount of force applied. So, the greater the force, the higher the turning effect. Also, we have the perpendicular distance between the line of action of the force and the point of support, and moment is directly proportional to the distance at right angle. So, if we take that the angle between this distance and the line of action of this force is 90, the moment you increase the distance from here toward this side, the higher the moment of force. And this one explains why it is easier to loosen a tight nut using a spanner with a long handle than the one with a short handle. That means that the force or the moment of force is directly proportional to the distance between the line of action and the moment and the point of support. And also, the SI unit of moment of a force is Newton meter. Then we have some activities where the force produces the turning effect. And it is also important to know that besides the force causing motion, there are those motions that may be linear or they form a straight line. But in this case, we are going to deal with the turning, whereby the force produces a moment whereby it will cause the body not to move but rotate around the axis. And in this case, the axis is now the pivot. And we have these activities which include closing or opening the door. So you realize that if you apply a lot of force in opening the door, it will open very easily because the moment of force is also great. Then we have steering a car by applying force on the steering wheel. There is also that turning effect, whereby the steering wheel is not moving, but it is just turning. You need to note that difference. Then we have turning of a water tap, or even opening the water using that tap. You have the turning. In the real sense, the tap does not move from where it is, but it just rotates around the axis. Also, we have loosing or tightening a nut using a spanner, there is also that rotation while doing that task. We have also cycling, whereby you have to bend maybe around some corners and therefore you have to turn, and that one produces the turning effect. We have riding on a seesaw, therefore we have the pivot and also the two maybe the two persons using the seesaw, they can be able to swing, and therefore we have the turning. Let us do one example to illustrate the moment of a force. Find the moment of a force about the pivot in the figures below. We have this figure here, and we are provided with the force, which is 20 newtons, and also clearly you can be able to see that this distance is perpendicular with this force here. Therefore, it means that the moment of a force will be force times perpendicular distance. Therefore, it means that the moment of a force about the pivot will be equal to the force, which is 20 newtons, multiplied by the distance, and it should be in meters. So you divide 40 centimeters or 40 by 100 to get 0.4 meters. And the answer is 8 Newton meter. It is important that you don't forget to write the unit, and the SI unit that is. So that illustrates the moment of a force, and hope that it has gone well with you. So whenever you don't understand, it is also good to revisit again, go through the notes till the point you will understand. And in case you don't understand, it is always good you consult with your teacher or maybe your peers, so that you get the best out of this, because in Colonet we are always ready for you, and we are ready to take part in shaping your tomorrow. And to test whether you have understood all this, it is always good you go through the assignment here. We have some very good questions that will help you to understand the moment of a force, and as you do them, ensure that you have written also the units wherever we have calculations. So the work remaining is for you. Just try to go these questions, and all the best as you work hard, as you prepare your brighter future, because we say that your future starts here, and in Colonet we are there for you. We will help you whenever need be. Thank you. Let us meet in our next lesson, which is the principle of moment.